Now if you look at any given line, it has a slope, and you can tell by looking at the slope of the line whether it's positive or negative. You don't have to calculate the slope to know whether or not this blue line has a positive slope or whether it has a negative slope. Here's how you tell. As you move across the line, so I'm going to draw this line and move it across so you can see what I'm doing. As I move across this blue line, and as I move from left to right, the direction the line moves will tell you whether the slope is positive or negative. So as I move from left to right along the blue line, it's going up, it's increasing, therefore it's a positive slope. The blue line has a positive slope. If you look at the red line, and as you move from left to right, you'll notice the red line is going down, and because it's decreasing or going down, it has a negative slope. The red line has a negative slope. So one more time, the slope of a line is determined by looking at the line and moving from left to right. As you move from left to right, if it goes up, it's positive. As you move from left to right, if the line goes down, it's negative. Now there are some cases where the slope neither goes down or up. These are special cases. So you may want to jot this in your notes. Just make a quick graph of each of these two lines. Where you place it on the coordinate grid is unimportant. Just notice that the red line is horizontal and the blue line is vertical. You may want to push the pause button and jot that down and then hit resume when you're ready to go. Okay, so if I look at this red line and I just pick 2 points, I could calculate the slope, and I can do that by finding the rise over the run. So if I start at point 1, I'm going to rise to get to point 2. Well, there is no rise. So to get from 1 to 2, I rise 0. And then I run 1, 2, 3, 4, 5. Did I do that right? 1, 2, 3, 4, 5. So my slope would be 0 over 5. Well, anything divided, or any number, 0 divided by any number, is 0. So this is a 0 slope. 0 slope. Now if I look at the blue line, I can do the same thing. I can pick a couple, I can pick a couple of points. That's not a very good point. And I can calculate the slope. And I can calculate the slope by finding the rise over the run. So I'm going to start at this point and go to this point. And I rise 1, 2, 3. And then I run. Well, there is no run because I'm not moving horizontally anyway, so 0 run. Unfortunately, in math, anytime you divide a number by 0, there's no definition for that. It's undefined. So this slope is an undefined slope, which we like to abbreviate as UNDI. Now how do you remember that? Because oftentimes students will get the two mixed up. Some will call this red horizontal line undefined, and some will call this blue vertical line 0. Here's the easiest way to remember. When I think of slope, I think of a skier. So I'm a skier, and if I'm a skier on this slope, that's not very much fun. That's 0 fun, sir. 0 fun, 0 slope. If I'm a skier and I'm on this blue slope, that could be fun for a little while, but eventually that's not going to be so fun. When you get to the bottom of this slope, your body might be splat, undefined. So here it is again. 0 slope, 0 fun. Undefined slope, your body is undefined. Hopefully that's clear. Now I could give you a couple of coordinates and ask you to find the slope. And one way to do it would be to graph the 2 points. So if I give you the point 2, 3 and the point negative 1, 2, you could take your graph, your coordinate grid, and graph 2, 3. So 1, 2, 1, 2, 3, here's the point 2, 3. And negative 1, negative 2, here's the point negative 2. And if you connect the 2 points with a line like this, now you can calculate the slope by finding the rise over the run. I'm going to rise up 1, 2, 3, 4, 5. That's up, or positive 5. And I'm going to run 1, 2, 3. That's 3 to the right, so that's positive 3. The slope, therefore, is 5/3, or 5 over 3. So if you're given 2 points, you can find the slope by graphing it and then calculating it. There is, however, a formula for finding the slope of a line, and it is as given. Slope equals rise over the run, or y2 minus y1 over x2 minus x1. Now that looks complicated, but take a second to write it down in your notes, write the formula, hit the pause button so you can copy it down, and then hit resume when you're ready. So here's what this formula means. These little numbers next to the y and the x are called subscripts. y2 and y1 are subscripted variables. Subscripted variables just mean it represents the same coordinate but in a different point. For example, if I were to label 1, 3 as point 1 and 4, 2 as point 2, then by using subscripted variables I could say this is the x-coordinate and this is the x-coordinate. How do I tell which x-coordinate is in which point? Well, if this is the x-coordinate of point 1, then I'm going to say this is x1. And if this is the x-coordinate of point 2, then I can call this x2. Same is true for the y-coordinates. This is the y-coordinate, this is the y-coordinate. But this is the y-coordinate of point 1, and this is the y-coordinate of point 2. So when you're given 2 points, it ends up being x1, y1, x2, y2. Now I would suggest that when you do these problems, you label the points like I just did with an x1, y1 and an x2, y2. Now you can find the slope of the line that passes through these 2 points by using the formula. And as you first get to know this formula, you might want to write it down every time so that you remember it. So I'm going to write it down. M equals y2 minus y1 over x2 minus x1. Now all I do is replace each of the letters y2, y1, x2, x1 with the coordinate that matches it. y2 is 2 minus y1 is 3 over x2 is 4 minus x1 is 1. 2 minus 3 is negative 1, and 4 minus 1 is 3. Therefore, the slope of the line that passes through 1, 3 and 4, 2 is negative 1/3. Pretty straightforward. So, here's a second coordinate. Negative 1, negative 3, and 5, negative 3. And for some reason, my smartboard is messing up, so I'm going to rewrite it over here. Take a second, hit the pause button, and calculate the slope for these 2 points, and then hit the resume when you're finished, and I'll show you the answer. Okay, so I'm going to start this problem by writing out the formula for finding the slope. M equals y2 minus y1 over x2 minus x1. One more time, I would suggest that you write it down every single time, at least in this lesson, until you have it memorized. Then I'm going to look at the 2 points, and I'm going to call the first point -1, -3, so its coordinates are x1 and y1. And the second point is 5, -3, so I'm going to call it x2, y2. Trust me, taking the time to write this really helps. If you don't write it, it's so easy to get the x's and y's mixed up and the 1's and the 2's. So label each coordinate with x1, y1, x2, y2. Then it's simple. You take the 3, the -3, which is y2, and you subtract -3, which is y1. Here's another issue. Notice both of these are negative and you're subtracting them. Be really careful about how you write the negatives. x2 is 5 minus x1 is -1. What you should notice is when you subtract a negative becomes adding a positive. Adding a positive. You finish up the problem. -3 plus +3 is 0. 5 plus 1 is 6. My slope is 0 over 6, which just equals 0. So to summarize it all up, you can find this in your book on page 295. A line that moves from left to right and goes up has a positive slope, and a line that moves down as you move from left to right has a negative slope. Lines that are horizontal have a slope of 0, and lines that are vertical have an undefined slope. Just remember the skier and what he does on each slope.